Cloudera Navigator Optimizer is the newest addition to Cloudera Enterprise, providing active data optimization for Hadoop success. Cloudera Navigator Optimizer provides the right visibility for successful Hadoop deployments. First off, helping our big data architects be able to offload the right workloads in the right way, allowing them to identify which workloads are the right fit for existing systems as well as for Hadoop and its SQL tools such as Hive and Impala, and being able to use information around compatibilities and complexities to allow them to develop a predictable offload strategy so that they can really understand what the true development costs will be and any of the associated risks. Once active with Hadoop, database administrators need visibility into what's actually going on within Hadoop. They need to understand the usage and then be able to optimize data models based on these changing needs. Navigator Optimizer provides this visibility into things like top users, top queries, any queries that may be causing performance issues or are long running, and then also provides recommendations based on Impala and Hive best practices to better improve the performance of these queries and these technologies. Part of the challenge when looking to offload queries to Hadoop is the ability to just understand what's going on due to the sheer volume of queries being generated every day across multiple different user groups and across multiple types of workloads. Some businesses even have millions of queries generated each day. This makes it difficult when they go try and see which queries may be causing issues, especially during peak times. You may have long-running queries that are really slowing down the rest of the analysis. There may be ETL pipelines that can be optimized or are breaking. And when you have many different users or high concurrency access, especially for BI, this can also cause a lot of strain on the system. Being able to understand what's going on and being able to get visibility into all of these workloads is critical when you go to offload some of these workloads or try to optimize performance. Queries can also be extremely complex, especially a lot of these legacy queries that have been adjusted and extended over time, or ones that are powered by BI tools. With such complex queries, these can be manually impossible to start to comb through to figure out where you even begin to start optimizing these, or where any of the incompatibilities may exist when you want to start bringing them over to Hadoop tools. Cloudera Navigator Optimizer allows you to break past all of this complexity and query volume, allowing you to very quickly understand what's going on with your SQL queries and be able to provide the right information that you need to develop a predictable offload strategy and be able to optimize these queries. So let's take a look at Navigator Optimizer in action. In this example, the user wants to offload their MicroStrategy reports to run on Impala. They can upload their existing SQL logs, and Navigator Optimizer will begin the analysis. We can see already that this workload has 6,500 queries loaded in, and Navigator Optimizer automatically does a risk assessment of these queries based on their compatibility with Hadoop tools such as Hive and Impala and their query complexity. We can also see the risk assessment at the report level, the user level, or whichever other categories are defined during the upload process. Here, it makes the most sense to look based on the reports and the risks associated with those. So we can see that the largest report has nearly 5,000 queries, with only 5 unique queries. So this signifies that this report gets run many times. Here, we can take a closer look at what is causing these queries to be high risk. So we can add them to the design block to dig in for deeper analysis. When we dig in further, we can see that there are 5 high-risk queries and 1 medium-risk query in this report. From the analysis that Navigator Optimizer automatically did, it can issue alerts based on potential issues that are discovered within these queries. We find that in the high-risk alerts, all 5 of these queries do Cartesian joins, which are very expensive joins that we want to avoid when moving these workloads over to Hadoop. Optimizer also makes suggestions to help adjust these risks, though for this, these queries need to be rewritten to add join conditions, or to adjust MicroStrategy reports to not include Cartesian joins when generating queries. For the medium risk queries, we see that these use a common filter. Selecting the right partitioning key is very important for Hadoop. If we scroll down, we can see that Navigator Optimizer has recommended designing a new partitioning strategy and provides a partitioning key design module that can recommend the right partition keys based on these common filters and popular joins. So, to improve the performance when moving these workloads to Hadoop, we would need to avoid Cartesian joins, and we'd evaluate how our tables are partitioned. Identifying these sorts of compatibilities with Hadoop can take weeks or months and can be a very manual process for architects and DBAs. Navigator Optimizer was able to provide this visibility and compatibility analysis nearly instantly as it looked through our existing workloads. Now, if we go back to the dashboard, we can also see that there is 88% duplication in this workload. So what exactly does that mean? Well, it means 88% of our queries have exactly the same structure. Only the unique queries really matter for our analysis, and that's a pretty small subset of the total 6,500 queries. So this information really lets us focus our efforts and reduces the scope of our analysis. We can dig into this information deeper and actually look at the top queries by instance count. Here we can see that 3 queries take up a large percentage of the workload. There are also 2 top tables that are most likely accessed by these queries. Additionally, we can view top queries by elapsed time. So we can see that a few queries take over an hour and that these 5 queries take up nearly 10% of our entire workload. The benefit of Navigator Optimizer is that it understands the complexity of each individual query as well as across the entirety of the workload. This complexity can be reflected in the join intensity graph below. These joins are profiled by the number of join tables in these queries. This chart shows most queries have a reasonable number of joins, which is good news when looking to offload to Hadoop. But there are a few many table joins that may need optimization. Now, let's switch over to a small ETL process that we'd also like to offload. We can see in this workload that there are no selects, but there's a lot of inserts, updates, and deletes, which is characteristic of these ETL workloads. From our risk assessment, we can see that nearly 80% of the workload is classified as high risk. Since this is an ETL job, queries must work together to perform the task at hand, so there are dependencies that we must consider when we're analyzing and ultimately planning our offload. Navigator Optimizer understands this data flow, so you can better understand the dependencies. The black boxes are tables, and queries are the blue circles. This allows you to identify significant data flows in the workload, and then you can then add these to the design block to figure out what we need to do to further reduce the complexity for a successful offload. When we dig in for a deeper analysis, we can see that this has given us 4 high-risk alerts. We can see that there are some unsupported commands, such as updates and deletes are not supported, so we'll need to rewrite these statements and consolidate them into batch inserts. There are some many table joins here, so it's recommended to do table denormalization. In the recommendation section, we also have a module to help evaluate the possibilities for this denormalization. Again, we see that there are some Cartesian joins, which will require rewrites, and the query has no filters, so we'll need to add in some filter conditions here. Finally, we also find queries with inline views, so for these, it may make sense to materialize them to better improve performance. For this data flow, it gives us 4 recommendations, and you can use the subsequent modules built into Navigator Optimizer to help optimize these queries or data models. Since this query will need to be rewritten to run on Hadoop, we should also see how the syntax is compatible for Hadoop tools. Since this is an ETL job, we want to look at compatibility with Hive. We can quickly see from the assessment chart the compatibilities and then further dig in for more specifics. Here we can clearly see the update and delete syntax errors, consistent from what we found with the risk assessment. We can then look into the query itself and quickly highlight the Hive incompatibilities. This feature alone reduces a huge amount of development time, significantly reducing the manual effort it would take to compile each query and then highlight and correctly identify the incompatibilities. With Navigator Optimizer, architects can now get the visibility and insights into their queries for ETL jobs, BI jobs, as well as further advanced analytics, so that they can properly assess the true development costs of offloading the right workloads to Hadoop in the right way. Once active with Hadoop, our customers need to be able to analyze Hive and Impala workloads, especially if there may be performance concerns, to make sure that the database administrator, as well as the rest of the business, can successfully stay on top of changing usage needs. In this workload, we've analyzed over 4,500 queries with low duplication. We also see that there's quite a lot of batch inserts as well. To start assessing usage and see opportunities for performance optimization, we can start to trace this down in multiple ways. First, we can look at the risk assessment across the entirety of the workload. So let's add the high-risk section to the design block and dig in for more details. For over 1,400 unique queries, we find 5 risk areas. Here, again, we see the opportunity to denormalize due to many table joins. We have queries with no filters, and this is for a majority of the queries, so this could be a major cause of performance concern. We would need to rewrite these queries to add filter conditions. We see there are many inline views, so this is another opportunity to materialize these views to simplify the queries and improve the performance. Again, Cartesian joins are found. And in addition, there are other kinds of query blocks, other than inline views, that are presented in large queries. You can see which queries have this very quickly and evaluate in the query text window itself. But let's also trace down any potential issues by user. So we can switch and look at the risk based on each user. We can easily see here that some users are writing more high-risk queries than others. We can see that this user, about 5 users down, is writing many high-risk queries, more so than the other users. So let's analyze this group of query from this user to see the cause of the performance issues there. So when we go to further evaluate risk, we can see that this user needs better coding practices. Their queries need to have the right filters in place, or necessary join conditions need to be added to avoid Cartesian joins. Finally, we can also look at risk by query type. So this sorts by select, insert, create, and others. We can look at the whole group of select statements that take 31 hours to run currently. Let's start to evaluate why that may be. So we'll add the high-risk select queries to the design block to understand the cause of this. Again, we can see the occurrence of these queries having no filters and many table joins, and this can cause for the lengthy time to run these queries. This information allows DBAs to understand the actual usage within Hadoop, so they can understand who are the users, what queries are they running, what tables are being accessed, and they can also focus their optimization efforts on high-risk queries or high length of time queries and provide recommendations based on Hive and Impala best practices. This allows them to ensure peak performance for these workloads as they run on Hadoop, and better allows their business and their users to successfully adopt and adapt to Hive and Impala technologies. Cloudera Navigator Optimizer is now generally available for customers with the appropriate Cloudera Enterprise licenses at optimizer.cloudera.com.